I was walking through the farmer's market the other day and I saw a stall just uh, piled high with root vegetables. And right in the middle, there it was, the beetroot, just sitting there looking all, I don't know, unassuming. This rough, purple, dirt-covered sphere.
They don't exactly scream superfood, do they? They just look like, well, like they came out of the ground.
Exactly. And it really struck me that there are very few vegetables in the culinary world that provoke such a violent, visceral reaction as the beet.
Oh, absolutely. It's a line in the sand.
It really is the cilantro of the underground world. You mentioned it at a dinner party, and half the room just lights up. They start talking about a nice roasted salad with goat cheese and walnuts.
It's the perfect combination.
And the other half makes a face like they've just been asked to lick a handful of potting soil.
It is an incredibly polarizing vegetable, and to be fair to the haters, that earthy flavor they complain about, it isn't in their heads. It's actually a chemical compound called geosmin.
Geosmin.
Yeah, geosmin. It is literally the exact same compound that is released by soil bacteria after a rainstorm. You know that incredible smell of wet earth?
Oh, I love that smell.
That's geosmin. So if you think beetroot tastes like dirt, well, chemically speaking, you are completely accurate. You are tasting the essence of the ground it grew in.
See, I always knew my taste buds were scientifically accurate. I wasn't being picky. I was just being, analytical.
Of course.
But here's the thing, and this is the reason we are dedicating this entire deep dive to a single root vegetable today. Regardless whether you want it on your burger or you want to banish it from your kitchen forever, we are seeing a massive shift in how the scientific community views this purple root.
A huge shift.
We aren't just talking about it as a source of fiber or a colorful side dish anymore. The sources we have in front of us today, and look, we are talking about a stack of systematic reviews, umbrella reviews, and meta-analyses from, 2024 all the way to early 2026. They're painting a picture of beetroot as something else entirely. It's starting to look less like food and more like a legitimate bioactive delivery system.
Exactly. And that is the distinction we need to make right out of the gate. I mean, if you are listening to this hoping for a recipe for borscht, you are probably in the wrong place. We are here to look at Beta vulgaris, the common beetroot, through the lens of rigorous clinical evidence.
Right.
The mission for this deep dive is to strip away the superfood marketing hype, which I know we both have a visceral allergic reaction to, and look at what the human data actually says.
And superfood is such a loaded term, isn't it? It usually just means we have no data, but it has a nice color.
Precisely. It's a marketing term, not a scientific one. But in the case of beetroot, the data is surprisingly specific. We aren't looking at these vague claims of wellness. We're looking at how this root vegetable interacts with our physiology to do some pretty heavy lifting, specifically regarding blood pressure regulation, the aging process, and even athletic efficiency.
Bypassing failing systems was the phrase that just jumped out at me from the research notes. That sounds like we are hacking the body, which, I love.
That's a great way to put it.
It suggests there is a back door into our biology that we can pry open with a vegetable. So before we get into the how, give us the lay of the land for the sources. What exactly are we basing this conversation on today?
Okay, so we're prioritizing high-level evidence. That means we've got umbrella reviews, which are reviews of other reviews. They're essentially the top of the evidence pyramid.
A view from the top.
Exactly. Then we have multiple meta-analyses of randomized controlled trials, or RCTs. And crucially, we are specifically focusing on human data. There is a lot of mouse research out there on longevity. And while that is interesting, mice are not tiny humans.
Right. A very important distinction.
So for today, unless we explicitly flag it as an animal model, we are talking about what happens when actual people, athletes, older adults, people with hypertension drink beetroot juice or eat the vegetable. We are looking for consistent patterns across populations, not just one-off miracles in a petri dish.
Okay, let's get into the mechanics of this then. I want to start with the mechanism because you teased this idea of the mouth acting as a chemical factory. When most people look at a beet, they see this deep, staining purple color. I got to assume that pigment is where the magic is. We're always told to eat the rainbow, right?
That is the common assumption, and it's a logical one. Those pigments are called betalains, and they are potent antioxidants. They give the beet its red color, and they have their own benefits, primarily in reducing oxidative stress and, a bit of inflammation. They are great compounds.
But not the main event.
No.
Yeah.
But if we are talking about the blockbuster effects, the blood pressure lowering, the endurance boosting, the vascular remodeling, the star of the show isn't the purple stuff. It is inorganic nitrate.
Inorganic nitrate, so NO3, O3
Correct. And here is where it gets really interesting and frankly a little bit weird biologically.
Mm.
Raw beetroot is incredibly high in this stuff. We're talking somewhere between 1,500 to 4,000 milligrams per kilogram. It's packed.
Right.
But nitrate on its own is biologically inert in the human body. It doesn't really do anything for you directly.
So we eat it, it just floats around in our blood and does nothing. That seems like a pretty poor evolutionary strategy.
Yeah, it does nothing yet. This is where this concept of enterosalivary circulation comes in.
Enterosalivary circulation. That sounds like a subway map for your digestive system.
It essentially is a loop, and I want to pause on this because it really highlights how complex our relationship with food is. Usually, digestion is linear. Mouth, stomach, intestine, blood, cells.
Right.
A one-way street.
Right.
Impact up with nitrate, it's a circle. So, step 1, you drink your beetroot juice. The nitrate is absorbed from your gut into your bloodstream very rapidly. It circulates around your entire body.
Okay, standard procedure so far.
But your body doesn't use it immediately. Instead, your salivary glands, the ones in your mouth, actively pump that nitrate out of your blood and concentrate it into your saliva.
Wait, hold on. So my body takes it out of the blood
Right.
and pushes it back into my mouth.
Exactly. It works against the concentration gradient. Your salivary glands have specific transporters. One is called silin, that literally grab the nitrate from the blood and shove it into the saliva.
Why?
Well, you end up with nitrate concentrations in your spit that are 10 to 20 times higher than what is in your blood.
Which implies the body wants it there. It's expending energy to move this chemical against a gradient back to the start of the line. Why would it do that?
Because of the microbiome. This is the beautiful symbiosis. We, as humans, lack the specific reductase enzymes needed to strip an oxygen atom off that nitrate, NO3 to make nitrate.
We can't do it.
We literally cannot do it ourselves. Our cells do not have the machinery. So we have outsourced this critical chemical step to the bacteria living in the crypts of our tongues.
The crypts of the tongue is a vivid and slightly disturbing image. We aren't just talking about the surface here.
No, the tongue is like a landscape. It has hills and valleys, papillae deep in those valleys where there is very little oxygen, live-specific anaerobic bacteria, species like Veillonella, Rothia, and Actinomyces.
Okay.
These bacteria are the factory workers. They use the nitrate as an electron acceptor for their own respiration. I mean, they aren't doing it to help us. They're doing it to breathe. They consume that nitrate, NO3, and they excrete nitrate, NO2R2, as a waste product.
So strictly speaking, this isn't a beetroot benefit. It's a bacterial benefit. We feed the bacteria nitrate, they give us nitrite, and then we swallow that nitrite to regulate our entire vascular system.
That is the correct framing. And that is why the 2026 perspective is so important. We used to think of this just as nutrition put fuel in the car. Now we view it as a critical host microbiome interaction. If you don't have those bacteria, the chain breaks.
Okay, so the chain is beet, nitrate in blood, glands put nitrate in spit, bacteria eat nitrate, spit out nitrite. Then what?
Then you swallow that nitrite-rich saliva. When it hits your stomach acid, that acidic environment converts the nitrate into nitric oxide, or NO.
Nitric oxide, that's the famous gas molecule.
It is a gas, and it is a hugely important signaling molecule. It won the Nobel Prize in Physiology or Medicine back in 1998. It tells the smooth muscle around your blood vessels to relax.
To just chill out.
Exactly. When those muscles relax, the vessels dilate, they get wider. That lowers blood pressure and improves blood flow to every organ in the body. The brain, the heart, the muscles, everywhere.
It's like a natural vasodilator. But here's my question. Why do we need a beet to do that? Doesn't our body make nitric oxide on its own? I thought that was a pretty fundamental function of being alive.
It is fundamental, and yes, we absolutely do make it. We have an enzyme called ENOS, endothelial nitric oxide synthase.
ENOS.
Think of ENOS as the body's internal primary factory for making nitric oxide. When you are young and healthy, that factory works great. It takes an amino acid called L-arginine, and it just churns out nitric oxide all day long. But here's the problem. As we age, specifically as we pass 40 or 50, that internal factory starts to get rusty.
Rusty in what sense? Oxidized.
Exactly. Oxidative stress damages the enzyme. It becomes uncoupled. It starts producing superoxide instead of nitric oxide, which is not good. It becomes less efficient. By the time you are 60, your natural ability to produce nitric oxide through this ENOS pathway might be half of what it was when you were 20.
So our natural ability to keep our arteries flexible and our blood pressure down just starts to decline by virtue of existing for a few decades.
Precisely. And this is why the beetroot pathway is so critical and why researchers call it a backup system. It provides a completely different road to get to nitric oxide. It doesn't use the ENOS enzyme at all. It uses the nitrate-no pathway.
So you're bypassing the broken aging machinery.
You're using the bacteria in your mouth and the acid in your stomach to keep the lights on when the main power grid is failing.
That is a powerful image.
Yeah.
We essentially have a dormant backup generator that just needs the right fuel, in this case, nitrate, to switch on.
Yeah.
So let's look at the results of switching that system on. You mentioned cardiovascular health. Is this just theoretical, or do we have hard numbers? Because in the world of nutrition, heart healthy gets thrown around a lot.
This is the area with the strongest evidence, bar none.
Yep.
When we look at the grade certainty ratings, which is how scientists grade the quality of evidence, blood pressure reduction gets a high to moderate rating. That is very, very good for nutritional science.
Okay, so what kind of numbers are we talking about?
Multiple meta-analyses from 2024 and 2025 show a consistent reduction in systolic blood pressure. That's the top number. In healthy adults, it drops by about 3 to 5 millimole Hg, but in people who already have hypertension, the drop is bigger, somewhere in the range of 5 to 9 millimole Hg.
Okay, let's unpack that, because I feel like some people listening might hear 5 points and think, is that it? That doesn't sound life-changing. My blood pressure fluctuates by 5 points when I stand up too fast.
It sounds small to an individual, I get that, but you have to look at it on the population level. A sustained 5 millimole Hg reduction in systolic blood pressure across a population is massive.
How massive.
That correlates to a roughly 14% reduction in stroke risk, a 9% reduction in heart disease risk, and a significant drop in all-cause mortality. In fact, that 5 to 9 millimole Hg drop is comparable to what you might see with the starting dose of some single antihypertensive medications.
That puts it in perspective. So it's a pharmaceutical-grade effect from a root vegetable.
It really is. And it brings us back to that concept of the responder. Who actually wins here? If you are a healthy 25-year-old with perfect blood pressure, say 110/70, you might not see a huge drop because your baseline is already low. Your ENOS factory is still working perfectly.
Right, you can't lower the floor if you're already standing on it.
Yeah.
The body has homeostasis mechanisms to prevent you from bottoming out your blood pressure.
Exactly. But the research identifies specific groups that are what you might call super responders. Older adults, those over 50, are the prime demographic because, as we discussed, their natural NO production is declining. If you give them the substrate, they respond beautifully because they need it.
They have a deficit that needs to be filled.
A huge deficit. Then you have hypertensive individuals.
Yeah.
The higher your starting blood pressure, the bigger the drop you tend to see. And then there's this really interesting group.
I saw something in the notes about postmenopausal women specifically.
Yes, this is emerging evidence from 2025 that is really exciting. Postmenopausal women appear to be particularly responsive. We know that estrogen plays a significant role in vascular health and specifically in upregulating that ENOS enzyme we talked about.
So estrogen keeps the factory running smoothly.
It does. When estrogen drops during menopause, vascular stiffness often goes up and blood pressure rises. It's a double hit. You lose the hormonal protection at the same time you have the age-related decline in ENOS function.
A perfect storm for vascular problems.
Correct. The beetroot pathway seems to be incredibly effective at counteracting that specific loss. It provides the nitric oxide that the body is struggling to produce hormonally, so it's almost like targeted nutrition for that specific stage of life.
That's fascinating. And it's not just blood pressure, right? There was another metric mentioned.
Yes, something called flow-mediated dilation, or FMD. This is a measure of how wide your arteries can expand when blood rushes through them.
So their flexibility.
Their flexibility and responsiveness. Imagine a fire hose. If it's old and stiff, it can't expand when the water pressure turns up. If it's new and flexible, it expands easily. Beetroot improves this flexibility by about 15 to 20% in some studies.
Which is the name of the game when it comes to longevity. Keeping the pipes flexible means less strain on the heart, less damage to the vessel walls, less risk of plaque rupture.
Absolutely. Stiff arteries are the enemy of longevity.
Okay, so that's the health and longevity side. But I know a lot of people know beets from the gym. You see the shots sold at checkout counters and sports stores. I've seen marathon runners chugging them. Is this essentially legal steroids? Or is it just hype?
It is an herbogenic aid, which means performance enhancing. The International Olympic Committee actually classifies it as one of the few supplements with strong evidence, alongside things like caffeine and creatine.
So it's legit.
Oh, it's legit. But it works differently. It's not a stimulant. It's not about making you feel wired or jittery. It's about efficiency.
Efficiency over power.
Right. The data shows that nitric oxide improves mitochondrial efficiency. The mitochondria are the power plants in your cells. They take oxygen and fuel and turn it into energy, ATP. Beetroot reduces the oxygen cost of exercise.
So using the car analogy,
Yeah.
usually to go 60 miles per hour, I need a certain amount of gas.
If your body is a car, usually to go 60 miles per hour, you need to burn a certain amount of gas, which is oxygen. With beetroot, you can go 60 miles per hour, but you are burning less gas. You become more fuel efficient.
So I can go further on the same tank.
Or go the same distance with less effort. In scientific terms, we see an improvement in the PO ratio, the amount of phosphate or energy produced per oxygen consumed. You're getting more bang for your buck with every breath.
That is wild. You're doing the same mechanical work for less physiological cost. That sounds like magic.
It feels like magic to a physiologist because usually efficiency is very hard to change. I mean, you can train for years to improve your efficiency by a few percent. Beetroot does it acutely within a few hours.
So what does that translate to in the real world?
It leads to improvements in time to exhaustion. If you are cycling at a fixed wattage or running at a set pace, you can simply hold that pace for longer before you hit the wall. The time trial performance improvements are usually around 1 to 3%.
Which, in a race, is the difference between first and fourth place, or a personal best versus a bad day.
In a competitive setting, yes, it's huge. But here's the counterintuitive finding that always surprises people. Who do you think benefits more? An Olympic marathon runner? Or a weekend warrior who plays soccer on Saturdays and runs a 5K once a month?
I would assume the Olympian. They are optimized machines. They squeeze every drop out of their body. They're the ones looking for that 1%.
You would think so, but the data says the opposite. Elite athletes, we're talking people with a VO2 max over 65, serious machines, are often non-responders.
Really? Why? Is it because they are already so efficient?
Yeah. It comes down to that eNOS enzyme again. In an elite athlete, their years and years of intense training have already upregulated their eNOS expression to the absolute genetic limit. Their arteries are as dilated and compliant as they can physically get. Their mitochondria are already operating at peak efficiency.
They have hit the ceiling of their hardware. There's no more room for improvement.
Exactly. If you dump more nitrate into their system, the bacteria will still convert it to nitrite. You will still see high levels of nitrate in their blood, but it doesn't translate to performance because the downstream machinery is already operating at 99% efficiency. There is no slack to tighten up. It's like pouring high-octane fuel into a tank that is already overflowing.
Whereas the weekend warrior.
The weekend warrior, like me, is operating at maybe 60% efficiency. Our eNOS is sporadic, our mitochondria are leaking protons, our oxygen usage is sloppy.
Thanks for the vote of confidence. I feel seen.
It's just physics. When you introduce exogenous nitrate to that system, you are tightening the bolts. You are plugging the leaks in the mitochondria. The change in efficiency is palpable because there was so much inefficiency to begin with. So if you aren't an Olympian, you are actually the perfect candidate for this.
That is actually encouraging for the rest of us. It's the one time where being average pays off.
It is. And there is another angle that is gaining traction in the 2024-2025 literature: recovery.
Okay, because usually we think about pre-workout, drink the juice, go run.
Right. But newer meta-analyses are looking at what happens after the workout. They found that beetroot consumption accelerates the recovery of heart rate variability, or HRV.
HRV is a huge metric right now. Everyone's watch tracks it. It's basically a proxy for how stressed your nervous system is, right?
Correct. It measures the balance between your sympathetic, fight or flight, and parasympathetic, rest and digest nervous systems. Higher HRV means you are recovered and ready to go. Beetroot improves that bounce back after a hard session.
So it helps you chill out faster, physiologically.
It helps your nervous system get back to baseline. And it also helps with muscle force recovery, specifically isometric strength up to 72 hours post-exercise.
So if I do a heavy leg day on Tuesday, beetroot might help me walk normally again by Friday. Not just feel better, but actually be stronger.
That's the idea. The mechanism is likely twofold. First, improved blood flow is clearing out metabolic waste products like lactate and ammonia more efficiently. And second, there are potential anti-inflammatory effects from the betalins reducing proteins like the C3 and C5, which are markers of inflammation.
So it's a double whammy. You perform better during the workout, and you recover faster afterwards.
For the recreational athlete, yes, it's a very compelling package.
Let's pivot to the brain. Because if it increases blood flow everywhere else, logic suggests it should send more blood to the brain, right? I see supplements all the time claiming beetroot for focus or beetroot for memory. Can we drink our way to a better memory? Is this a smart drug?
This is where we need to put on our skeptic hats and look very closely at the data. The brain-boosting claims are everywhere. but the evidence is graded as low or inconclusive.
That's a buzzkill, but I appreciate the honesty.
Well, it's nuanced. We can see increased blood flow to the brain in scans. That's true. If you put someone in an fMRI, we see better perfusion, particularly in the prefrontal cortex, the area responsible for executive function, decision-making, working memory. The plumbing is definitely working better.
But better plumbing doesn't mean better thinking.
Not necessarily. That increased blood flow doesn't consistently translate to better test scores in healthy young adults. If I give a healthy 25-year-old a beetroot shot, they don't suddenly become a grandmaster at chess. Their cognitive function is already pretty optimal.
So, similar to the elite athlete, if the tank is full, it's full.
Precisely. However, there is some promise for older adults or those with metabolic syndrome. If someone has compromised blood flow to the brain due to aging or type 2 diabetes, then restoring that flow might help. There are some studies showing improved reaction times in older adults, but for the average healthy person looking for a nootropic effect, it's probably not going to change your life.
Got it. So manage expectations is not a magic intelligence potion. What about longevity then? We touched on the backup generator for aging, but does it actually make us live longer?
That is the million-dollar question. And look, we don't have 50-year trials where we feed one group beets and the other group nothing and see who dies first. That study doesn't exist. It's too expensive and takes too long. But what we have is proxy data.
Proxies like what? What can we measure instead?
Frailty risk. There was a significant cohort study mentioned in our stack that looked at older women, and it showed a 23% reduction in frailty risk in those with higher nitrate intake.
Frailty is a specific clinical term, isn't it? It's not just about feeling a bit weak.
Right. It's a clinical syndrome characterized by weakness, slow walking speed, exhaustion, and low physical activity. Frailty is a huge predictor of mortality. If you become frail, your risk of falls, hospitalization, and death skyrockets.
So if beets reduce frailty, they are keeping you functional and independent for longer? They're improving your health span.
Exactly. And we infer longevity benefits from the cardiovascular markers. We know that lower blood pressure and better endothelial function are strongly correlated with a longer, healthier life. So while we can't say beets add 5 years to your life with certainty, we can say beets significantly improve the biomarkers associated with a long, healthy life.
That's a fair scientific compromise.
Yeah.
Now, I want to get to what I think is the most critical part of this deep dive, the user manual. Because when I was reading the notes on the bacterial pathway, specifically the bit about the tongue, I had this sudden horrifying realization that I might have been doing this wrong for years.
Most people do. There is one specific mistake that completely, and I mean completely, nullifies the cardiovascular benefits of beetroot.
The mouthwash trap.
The mouthwash trap. It is so critical. Remember, we need those bacteria Veillonella and Rothia to turn nitrate into nitrite. If you use a strong antibacterial mouthwash, like chlorhexidine, or even just a regular strong antiseptic mouthwash from the drugstore, you are carpet bombing those bacteria.
You're killing the factory workers.
You are wiping them out. And the data is just stark. There was a landmark study, it's relatively old now, but it's been confirmed repeatedly in the 2024 reviews where they gave participants chlorhexidine mouthwash. We aren't talking about a 10% drop in effectiveness. They saw the salivary nitrite levels crash by over 90%.
90%. So you are effectively sterilizing the factory.
You are, and the recovery isn't instant. If you use a strong antiseptic mouthwash in the morning, those bacterial colonies don't just bounce back in an hour. It can take 24 to 48 hours for the nitrate-reducing capacity of your oral microbiome to fully recover.
So if someone is a daily user of something like Listerine or a prescription rinse, and they are drinking beet juice for their blood pressure?
They are essentially drinking expensive purple sugar water. They might get the fiber, sure, they'll get the vitamins. But the cardiovascular effect, the vasodilation, it's gone. You have effectively washed away the medicine.
That is mind-blowing. You could be drinking the most expensive, high-quality organic beet juice every single day, but if you brush your teeth and gargle right before or after, you're neutralizing it. Does toothpaste count?
Strong antiseptic toothpaste can have a similar effect, though usually less severe than the liquid mouthwash because the contact time is shorter. But chemicals like sodium lauryl sulfate or triclosan can be inhibitory. The general recommendation now from sports nutritionists is to avoid antibacterial agents for at least 2 hours before and 2 hours after nitrate consumption.
So drink your beet juice, wait a couple hours, then brush your teeth. Give the bacteria time to eat the nitrate and convert it.
Exactly. You have to respect the ecosystem in your mouth.
Okay, that is takeaway number one, a big one. What about the stomach? You mentioned acid was important.
Yes. Step 2 of the conversion happens in the stomach. We need strong stomach acid, a low pH, to turn that nitrate into nitric oxide. This brings us to proton pump inhibitors, or PPIs.
The acid reflux drugs, omeprazole, Nexium, that class of drug.
Right. Millions and millions of people take these. They work by raising the pH of your stomach, making it less acidic. And the data shows that PPI users may not see the cardiovascular benefits of dietary nitrate because that final conversion step is blocked. The chemistry just doesn't happen at a higher pH.
Wow. So if you're on PPIs for chronic reflux, this pathway might be closed to you. That is really important to know.
It's a major confounder in the research and in real life.
Let's talk about the beets themselves. How much do we need to eat? Can I just have a slice of pickled beet on my burger and call it a day?
Unfortunately, no. You need a clinical dose to see these effects. In the studies, the target is roughly 300 to 600 milligrams of nitrate. That equates to about 5 to 9 millimoles for the chemists out there.
Translate that to grocery store terms. If I go to the store right now, what am I buying to get, say, 400 milligrams?
Okay, so if you are buying those concentrated beetroot shots, the little 70 milliliter bottles you see athletes use, usually 1 or 2 of those is the gold standard because they were standardized.
Yeah.
The manufacturer tests the nitrate levels. You know exactly what you are getting. That's the most reliable way.
And if I'm juicing at home?
You are looking at about 250 to 500 milliliters of raw juice. That's a tall glass, a substantial amount.
That is a lot of juice. And beet juice is potent. What about whole beets?
You'd need about 2 to 3 medium beets, but there is a huge catch with whole vegetables. The nitrate content varies wildly based on the soil they were grown in, the time of year they were harvested, the type of fertilizer used, and how long they've been in storage.
So the beet I buy today could be completely different from the one I buy next week.
Very different. One beet might have 200 milligrams of nitrate, another one from a different farm might have 50 milligrams. The variability is high. That's why researchers love the shots for trials. But for general health, eating a few beets a day is great. For a specific performance goal, where you need to guarantee that 400 milligram dose, you might want the standardized concentrate.
What about powders? They're convenient.
Powders are great for convenience, but you have to read the label. Look for one that is standardized for nitrate content. If it doesn't say how many milligrams of nitrate are in each scoop, you have no idea what you're getting.
And cooking matters, right?
It's a huge factor. Nitrate is water soluble. If you take your beets, chop them up, throw them in a pot of water, boil them for 30 minutes, and then dump that dark purple water down the sink.
You just poured your blood pressure medication down the drain.
You did. You kept the fiber, maybe some vitamins, but the nitrate is gone. You want to roast them, steam them, or juice them raw. Do not boil and dump the water.
Roast, steam, or juice.
Got it.
And timing. If I'm that weekend warrior trying to beat my 5K time.
You need to plan ahead. The whole process takes time. Peak plasma nitrate levels hit at about 2 to 3 hours post-ingestion.
So don't chug it at the starting line and expect a miracle?
No. If your race is at 10:00 a.m., drink your shot at 7:30 a.m. You need to give the bacteria time to do their work and for your stomach to convert it. Give the factory time to spin up.
Okay, let's talk about the side effects. Because there is one that sends people to the emergency room in a panic. I'm pretty sure almost everyone who eats a lot of beets has experienced this moment of pure terror.
Yes. Bacteria.
Beeturia. The red toilet bowl.
It happens to about 10 to 14% of the population. It's a genetic quirk where you can't fully metabolize the baleen pigment. It passes through your kidneys and turns your urine, and sometimes your stool bright pink or red.
And people think they're dying. They think it's internal bleeding.
They think it's a major medical emergency. It is totally, completely harmless. If you ate beets yesterday and the toilet looks like a crime scene today, please don't call the ambulance. It's just the beets.
Good to know. But there are some real safety concerns we should cover, right? Kidney stones.
Yes, this is a real caution. Beets are extremely high in oxalates. Oxalates can bind with calcium in the urine to form calcium oxalate kidney stones, which are the most common type.
So this is a problem for people who are already prone to them.
Exactly. If you are someone who is a stone former, if you have a history of them, you need to be very careful with high daily doses of beets or concentrated juices. You are loading up on the very thing that forms the stones.
So if you have a history of stones, maybe skip the daily beet protocol.
Or at the very least, consult your doctor or a registered dietitian. You definitely shouldn't be chugging concentrated shots daily without medical advice in that situation.
What about other interactions?
The other one is surprisingly with hypotension.
Low blood pressure.
Yes, because beetroot lowers blood pressure if you are already on heavy blood pressure medication, or if you are taking PDE5 inhibitors.
Like Viagra or Cialis.
Exactly. Those drugs also work on the nitric oxide pathway to create vasodilation. That's how they function. If you stack a high dose of beetroot nitrate on top of them, you can cause a synergistic effect where blood pressure drops too low. You can get dizzy, faint, or even pass out.
So don't mix your beets with your Viagra without talking to a doctor. That is a very specific but very important warning.
It is safety first, always.
One last question on the varieties. I see golden beets at the store. I see those cool candy cane striped ones, the Chioggia beets. Are they as good? Do they have the same effect?
They are delicious, but almost all of the clinical trials, really 99% of them, use red beetroot, Beta vulgaris. We assume the other varieties have nitrates, but their betalain profile is different. That's why they have different colors. We don't have the same level of evidence for them.
So if you want the evidence-backed results,
stick to the red. That's where the data is.
stick to the red. Okay, let's wrap this up with a summary. We've covered a lot of ground, from tongue bacteria to kidney stones. If someone listening wants to implement the perfect beetroot protocol based on this deep dive, what does it look like?
Ideally, you are looking at red beetroot, either as whole food, juice, or a standardized concentrate to ensure you're getting the right dose. You are aiming for about 400 milligrams of nitrate per serving.
Which is a couple of beets or a big glass of juice.
Right. You'd take it daily if you are managing blood pressure, or about 2-3 hours before exercise if you are looking for a performance boost. You steam or roast, never boil, and dump the water. And crucially, the most important part, you ditch the antibacterial mouthwash.
Simple, effective, and backed by a surprising amount of science.
Yeah.
It really does change how I view this vegetable. It's not just a salad ingredient, it's a tool.
It is a prime example of food as medicine, but not in the woo-woo vague sense, in the mechanistic sense. We understand the molecule, we understand the pathway, and we see the clinical outcome. It empowers us to take some control over that aging process.
And it leaves us with a provocative thought, doesn't it? If beetroot, this humble, dirt-flavored root, holds the key to unlocking a dormant backup generator for our blood vessels,
It begs the question, what else is out there? We often accept declining blood flow and rising blood pressure as these inevitable parts of getting older. Beetroot proves that with the right chemical precursors, our bodies are capable of much more than we give them credit for. It makes you wonder what other dormant pathways are just sitting there in our biology, waiting for the right vegetable to flip the switch.
I love that. I'm going to be looking at the produce aisle very, very differently next time. Maybe there is a secret kale pathway we haven't found yet.
Let's not get ahead of ourselves, but the potential is certainly there to be explored.
Thank you for unpacking all of this with us. It has been a fascinating look at the power of nitrate. For everyone listening, check the show notes for the links to the meta-analyses we mentioned, and maybe give the purple root a second chance.
Just remember to warn your family about the bacteria first.
Absolutely. No unnecessary panic in the bathroom. We'll see you next time on The Deep Dive.